4.1, we're working on divisibility, and we had gotten a really good distance into this particular lesson, talking about some different divisibility properties, some that are generally for all things, some that are very specific for specific divisibility by certain numbers. So let me just remind you of a couple things that we're going to be encountering along the way again, that are the most sort of encompassing. We had this chart, and this chart talked about what happens when you have two numbers that are divisible, or if one's divisible and the other one's not, and whether or not they divide by that common value that they started out dividing by or not dividing by. And it talked about it in terms of addition, and it talked about it in terms of subtraction. And then we had a bunch of individual rules for different numbers. So in order for it to be divisible by 2, it has to end in a 0, 2, 4, 6, or 8. Or other words, it has to be even. To be divisible by 5, it has to end in 0, 5. Divisible by 10, divisible ending in 10 and ending in a 0. The divisibility test for 4 uses the last 2 digits because 4 is 2 squared. And the divisibility test for 8 uses the last 3 digits because 8 is 2 cubed. So we have 3 digits. Divisibility for 3 and 9 talk about adding all the digits together. So you add them all together. If it's divisible by 3, then it divides by 3, the original one. If it's divisible by 9, the original number divides by 9. 11 had this weird bouncing back and forth between digits, adding them up and doing a subtraction between those sums. And then the divisibility rule for 6 we're going to come back to a little bit at the end of the class. And it talks about this very interesting fact that we saw work for 6, because we talked about it, and we saw it not work for 8. So if we have divisibility by 6, we can actually just test if it's divisible by 2 and 3. But we talked about the fact that that doesn't work for all values, but it works for some values. And there's a commonality among the ones it works for and a commonality among the ones it doesn't. So we'll come back to that idea a little bit more. And we're on example 3. Okay? So that's a real quick rundown of where we went to last time. All right, so example 3 has us looking at numbers that are divisible, especially on part A and B, by something we don't have a property for. We don't have any property or rules for the number 17, right? Like that's a kind of large prime number. It's not one of our listed numbers. So taking a look at the first one, 34,051, we're trying to decide if that's divisible by 17. And it's not legitimately wanting you to actually divide by 17, nor is it wanting your calculator to divide by 17. It's wanting you to think about the numbers that you're seeing, the number that you're seeing that's present there, that 34,051, and see if you can make a reasonable statement based on what you know about those numbers. So what do you think? Is it going to be divisible? What if I give you a smaller number, like just 34? Is 34 divisible by 17? Okay, so Kinsey sounded for sure yes. So Kinsey, I think you have an idea as to why you think that. So why do you think it works? 17 times 2 is 34. Okay, so the first part of this number is 34, right? It's 34. So if it just said 34 or 34,000 or 3,400, it would work being divisible by 17, right? Okay, so what about the ending of this? 51. Why?
I don't know, I just put in my calculator.
Yeah. So the calculator's great, but if you're in 3rd grade, you're not using it, right?
34 plus 17.
Okay, so 34 was the number that it was times 2, right? So if I add another 17 to it, I've equivalently done times 3. Okay, so 34, I'm going to write down what you guys have just said here about 34. 34 is 17 times 2. And it is true that 51 is actually 17 times 3. Okay, is everybody good with that so far? So it's almost like you can take these numbers and you can break them into pieces that work. So I can take 34 and I can divide that evenly. So I didn't write that right, sorry. 17 is what I wanted to write first. 17 divides 34. And 17 will divide 51. So if we were to do this with long division, right? you would divide by the 34 first, right? Divide the 34 first by the 17, and you would have it come out perfectly with no remainder, right? And then you'd move on to the 51, and you'd do the same thing. The 51 would be nicely and evenly divisible by the 17 as well. So this one is a yes. It does work because each of the components work. And if you remember, one of our mental math strategies for division was something that was called breaking up the dividend. That's what I just did here. I took the number 34,051 and I broke it apart into two pieces. And I said, hey, look, this is pretty nice. It divides evenly on the first part. So let's look and see if it's dividing evenly on the second part. And the answer is yes, it does. So therefore, it will divide completely. Okay. How about the next one? 19,031. Is that divisible by 19? No. Kaylee says no. You're right, Kaylee. Why?
19 doesn't divide in the third.
Right. So the 19 divides the 19 at the beginning just fine, right? That part's good. So we almost have the feeling that we're trying to do this, breaking it up again like this. But when we try for the second part, the 19 does not divide the 31. What if it said 38? Then it would work. 19 does divide 38, but it doesn't divide 31. What part C? Part C is not wanting you to multiply that value out. Okay, so our goal is not to multiply 2 times 3 times 5 times 7. But is 2 times 3 times 5 times 7 divisible by 5? Okay, it is yes.
I don't know if this is like a valid response, but is it because if a 5's involved, it's gonna?
That's part of it. Yeah, there is a 5 involved. It's not just that it's involved. There's more to it than that.
Because anything that's multiplied by 5 is gonna end up 0 or 5.
Okay, so that's really good justification. I am multiplying by the number 5 here, right? There's a 5 in this list of multiples. That is going to force this number to either end in a 5 or a 0. Right? That's the divisibility property of 5s. Okay? So if the whole number then ends in a 5 or a 0, then the whole number itself would also be divisible by 5. So you can reason through it that way. That works really nice. There's actually a far simpler reason, but what you described works. Okay? When we talked last time, let me see if I can find the screen where I wrote it down. Yeah. We talked about some vocabulary. This was our screen where we introduced words like factor and divisor and multiple. And we said if 2 divides 6, that's what this first statement says, 2 divides 6. It means 2 is a divisor of 6 or it's a factor of 6. Right? So 2 is a factor or divisor of 6. So if we're trying to decide if 5 divides 2 times 3 times 5 times 7, we can ask ourselves, is 5 a factor of 2 times 3 times 5 times 7? And the answer is yes, that's factored form. It's the simplest one that we could see here because it's already broken down into its factors, and 5 is one of them. So this 5 is a factor. So yes, this is true. What you wrote down would be just, or what you had said before, Kinsey, would be just fine. But more basic level is that yes, and this is because 5 is a factor of 2 times 3 times 5 times 7. We could also say that 7 is a factor, right? And 3 is a factor, and 2 is a factor. There are 4 factors, prime factors anyway, written down in this factorization. All 4 of those will divide this number. What happens if I add the number 1 to the end of this? It's going to make it an odd number, that's true. It isn't so much that it's an odd, because odd's not a problem necessarily. I can have odd numbers that are divisible by 5. Okay, why?
It's not going to end in 0.
Okay.
And then a 1 or 6.
Okay, good. So this will, well, the answer is no. Let me put the no first. No. This will end, and I like that reasoning, will end in a 1 or 6, I think you said. Why?
So when you multiply everything by 5, well, you're gonna end up with something with the 0 or 5, but then when you add 1, it makes it a different answer.
Okay, how does 2 times 3 times 5 times 7 end?
And a 0 or 5.
Yeah, it ends in a 0 or 5. And that's from our discussion earlier, right, Kinsey? It has to end in a 0 or 5. So if we add a 1 to something that ends in a 0 or 5, it's now going to end in a 1 or a 6. And if it ends in 1 or 6, it can't be divisible by 5. Okay? What would I do, or what would happen if this same question were asked, but it didn't say plus 1 at the end, it said plus 15? Would it?
Well,
It'd be
it
good.
It would work. How come?
Still in 5 or 2.
Yeah, it would actually then still end in a 5 or a 0. Another way you can think about this is that the 2 times 3 times 5 times 7 divides by 5, but 15 divides by 5 as well, right? Each of the individual components or pieces divide by 5, so their sum has to also divide by 5. And if we think about it from that perspective, we're actually utilizing theorem number 1 here. If 5 divides the first number and 5 divides the second number, 5 divides the sum. So another way to argue why that first one with the plus 1 there we go. Another way to argue why this plus 1 doesn't work is that while 5 divides the first piece, 5 doesn't divide the second piece, right? So it's actually, I don't want to flip back over there, but it's actually case number 2 on that chart. 5 divides one piece, 5 does not divide the second piece, therefore it won't divide the sum. Okay? All right, think about this one. We've got the number 24. 24 divides our number. Whatever our number is, it's 24 or bigger, and 24 divides it. What other numbers would also then have to divide our number m? 2 would be one of them. Okay.
6.
Okay. 12. 3, so I'm going to put it in there in the middle since we skipped it. There's more. There's 2 more, I think. 8, 8. 24 we already know does. That's what we're given. 1. Yeah. Okay, so you guys came up with the list, right? What were you doing when you came up with this list? You were multiplying what?
those numbers. See, I was trying to figure out what goes in.
Okay, so you were actually looking at numbers that divide 24, right? Yeah. So in general, anything that divides 24 will divide m. And so we just need to get a list of numbers that divide 24. So somewhere along the way, you guys were like, I think I got them all. And I was like, nope, there's some more, right? So how could we make sure that we catch all of them maybe a little bit more easily? So we're kind of like throwing things out there. Any thoughts about how we could do that in a more organized pattern?
Go in order.
You could go in order. You could say, does 1 work, does 2 work, does 3 work, all the way up till you get to something where you decide you've gone far enough. There's another way to do it too. Or at least maybe a combination of that with something else. Take a look at this. I'm going to put 24 in our list because it'll be easier to see what I'm doing. If I pair these up, what do you notice? Yeah, all of our multiples, or all of our factors of 24, have a multiplication pair, right? They pair up with something that equals 24. These happen in pairs. And that's kind of nice because that actually tells us where it ends as well. Once we get to the middle here, between 4 and 6, right? 4 times 6. There's nothing else in between that works, right? The only number between 4 and 6 is 5, and it doesn't work. That tells me I've run out of possibilities. It tells me I've run out of pairs. So the problem is that when I get to 12, I have to ask myself, well, does anything bigger than 12 work? And it might stump you for a little while. Or you might think, I don't know exactly how far I need to go up to check, right? If I just go one at a time, when do I get to stop checking? Do I have to go all the way to 24? I don't, but how far do I have to go? You actually only need to go to the number 4 if you're working in pairs. Because you can actually pair them up. You can go, okay, well, look, 1 and 24 to go together. 2 works. 2 and 12. Oh, 3 works, so it's 3 and 8. Oh, and the number 4 works, so it's 4 and 6, and I've run out of numbers to try. So if you make them in pairs as you're sort of looking for them, it's easier to know when you're finished. Do you see that connection okay? Yeah? Okay. You're going to have some opportunity in your homework to do questions that look a lot like A, B, and C here on number 5. They give you a partially created number, 543,220 something, and they want you to fill in the blank to make it divisible by certain values. Okay? So if I want this number, whatever it is, to be divisible by 2, what numbers would show up in that last place in that blank?
All the possible numbers.
Every possible number that can go there. There's only single digits, so we don't have an infinite number or anything of them.
7, 2, 4, 6, 8.
Mm-hmm. Exactly. Okay, that one's easy to look at and see. The next one's not so easy to simply look at. I need to know what numbers can go in the blank to make it divisible by 3. So what's my property for 3's? The sum. So I kind of need to know what I've already got to work with in terms of the sum, right? So let's actually figure out what I have. Well, I have 5 plus 4 plus 3 plus 2 plus 2. And I know I'm going to need another number here in a minute, but let's just see what I have so far. What do I have so far? 16. Okay, so let's think about what we do if we just went one at a time for the moment. If I put a 0 in the blank, I'd add 16 to 0. Would it be divisible by 3? No. What if I put a 1 in the blank? My 16 would become a 17. Is 17 divisible by 3? No. What if I put a 2 in the blank? 2 would work, right? If I took 16 plus 2, I'd have 18. 18 is divisible by 3. So one of my answers here is the number 2. I can go step by step through this. That will work just fine. So let's try 3. What if I put a 3 in the blank? Nope. 4. Nope. 5? Yeah. 6? Nope.
Oh, you're just going to go up 3.
Yes, you are. Once you find the first one, 2, right? 2 worked. It was an 18. I need to add 3 more to it in order for it to work again. So once I find the first one, the 2, I should be able to find the next 2, or however many more there are, depending on what we're working with on this property, pretty quickly. So what's the next one after the 5? It'll be an 8. So these are the 3 numbers that work. These are 5 numbers here that work. What if I want the number to be divisible by 6?
If it's divisible by both 2 and 3.
Mm-hmm.
Oh, so we just put the numbers. They both have.
What'd you have?
2 and 8.
2 and 8. And why, Kaylee?
Because it's the only numbers that they both have
Yeah.
in common.
It's what they have in common. I have to be divisible both by a 2 and a 3. So if it ends in a 2, it's divisible by 2 and 3. If it ends in an 8, it's divisible by 2 and by 3. So I'm looking for something called an intersection, right? Intersection of sets, chapter 2 stuff. Shake your head if intersection sounds familiar. Okay, good. That's good. All right, 2 and 8. Yeah, it's a 2 and an 8. 2 and 8 will work. but nothing else would. And notice 2 and 8 are how far apart?
6.
6. So that sort of makes sense too, right? 2 and 8 are 6 apart. Cool. All right, let's take a look at some questions that are kind of some comprehensive connection questions. We're going to answer the following and we're going to justify our answer. If a number is divisible by 5, can it be divisible by 10?
Yes.
Yes. So the first question is, can it be? And the answer is yes. Can you give me an example, Kenzie?
10, 20, 30.
All right, 10, 20, 30. They're all divisible by 5, and they're also divisible by 10. Must it be?
No.
No. And an example.
5, 15, 25.
So what is the distinguishing factor between our lists? The 0 or the 5, right? In particular, it's how they end. So all of these numbers that we've listed are divisible by 5. Some are also divisible by 10 and some are not. So just because I know something's divisible by 5 does not automatically mean that I know if it's divisible by 10. It might be, but it might not be. If a number is divisible by 10, can it be divisible by 5?
Yes.
Yes. Example?
10, 20, 30.
10, 20, 30. All divisible by 10, also divisible by 5. Must it be?
Yes.
Yes. Why?
Because everything that 10 is divisible by, so is 5.
Correct. I feel like that's just saying because it is, though. Think about properties of rules, like the rules for what we know.
Because they all end in 5 or 0.
There you go. Do they end in 5 or 0?
They all unzip in 0.
Okay. They all end
Oh.
in 0. That's what it means to be divisible by 10. At least that's a property of being divisible by 10. They all end in 0. And those numbers are all divisible by 5. That's the property of 5s, right? If it ends in a 0, it's going to be divisible by 5s. It can also end in a 5, but that doesn't mean it has to. Right? If it ends in a 0, it definitely will be divisible by 5. All right, let's take a look at a clever one.
Oh gosh.
It sounds like a terrible statement. It's that this is actually really quite clever. A number in which the digits, except 0, appear exactly 3 times are divisible by 3. For example, 777, 555, 222, or 414, 143, 313, right? Every number that's included is included 3 times. Those numbers are all divisible by 3. To explain why this would have to be true.
Because,
Add.
yeah.
So they're going to be added together 3 times.
Yes,
So that means they'll divide by 3.
correct. You're exactly right. So I'm going to write that out. Because you're adding them 3 times. So I'll just use the 7s because that's one of the first ones that lists. 7 plus 7 plus 7 is the same as 7 times 3, right? And this divides by 3. Now, we're not just doing a number 3 times. It has to be a number 3 times, or it can be anyway, a number 3 times and another number 3 times and another number 3 times, like this list up here. But how do we get that part? Well, we get that part back from that list of properties that says if it divides this piece and it divides this piece, it divides their sum, right? So 7 times 3, we have 4 times 3, and 2 times 3, and it divides by 3.
Isn't it 5 times 2?
I have 5? It is a 5. Got off on my list. It was the next one had a 4 in it. Thank you. Because each divide by 3, so does their sum.
Why did you put dividers by 2?
Well, because I got distracted. So does the sum. Thanks, we got it fixed. Yeah, each of them individually divides by 3, so their sum will be dividing by 3. That's one of the properties that we had in that table. Must this statement be true for a number to be divisible by 3?
I don't understand.
Do you have to have numbers repeated 3 times in order to have numbers that are divisible by 3? Nope, this is not a true statement. Can you give me an example? 39 would be great. 39. 39 definitely doesn't have repeated numbers, right? There's a 3, there's a 9, you're done. Does 3 divide it? Yeah. And in fact, every number that you want to use below 39 that divides by 3 works too, right? Like your multiplication tables like 3, 6, 9, 12, 15. All those numbers, same thing. None of them actually have the ability to be written in 3, groups of 3 numbers that are added together. Okay, so here's what I want you to do. We got group work partners a little bit late last time, so I'm going to keep your group work peoples the same for today because I forgot to switch them up. So go ahead and sit where your group person is. So Lisa and Autumn, Abby and Kaylee, Mackenzie. And I'm going to make a list on the board. We're going to explore this idea of divisibility by 6. Okay, when does it work? When does it not work? And I'm going to make a list of examples where it works and examples where it doesn't work, or non-examples. So and your goal in your group, and I want you to kind of like be spread apart enough, so maybe Kaylee and Abby, if you guys can move forward some, that you're not listening to each other, because I want each of the groups to really think through together by yourselves without trying to spoil it for someone else who's still trying to think through it, because probably one group's going to get it and not all of you get it at the same time. Like, that seems reasonable. These are non-examples. Yeah, or you can put it at the bottom or flip your paper over or something like that.
So this isn't a part of the group work?
This is not a part of your group work. No, this is just something we're going to do before we get to the actual formal group work. Okay, so we talked about the fact that if a number is divisible by 6, we've got this if and only if statement that says that it has to work by 2 and 3. We can test the 2 and the 3, guarantee it's divisible by 6. We also talked about the fact that the 8 doesn't work to do this. I can't do 8 and then 8 be 2 and 4. Like, that won't work. Right? I can't just test 2 and 4 and it's automatically divisible by 8. For example, the number, for example, the number 12, I think was the number we brought up. 12 is divisible by 2 and 4, but it's not divisible by 8. Right, so that's a non-example. Okay? So what I'm going to do is I'm going to create a list of examples and a list of non-examples. And you're trying to figure out what the examples all have in common, what the non-examples all have in common, and why the lists are separated. Why some of them work and why some of them don't. You're looking for common things between them. Okay? So, let's see. We can do 15. And 15 is 3 and 5. We can do 30. 30 is 3 and 10. We can do 12, and it's 3 and 4. Okay, let me do some non-examples now. I can't do 12 as 2 and 6. I can't do 16 as 4 and 4. I also can't do 16 as 2 and 8. I can't do 25 as 5 and 5. Okay, I think that's probably, oh, they're uneven now. We need one more example. I can do 24 as 8 and 3. Okay, so what you're trying to do is you're trying to see what the list of the numbers on the left has in common that makes it work, and what fails on the list on the right to make those work. Once you think you figured out what it is with you and your partner, I need you to come up with either an example or a non-example for us to add to our list. Okay? So chat with each other.
I'm confused.
Okay, so Abigail noticed that my list all had a 3 in every one of them. That's a good thing to notice,
But that's not it.
but that's not it. Yeah.
This is boggling my brain.
Maybe I should pick some numbers. Insane. Guess what they would put. 17. Two numbers. Over here. Okay, let's pick a different number. Um. Is that one?
So our goal is that we're starting with one of these larger numbers,
Oh.
and we want to break it down in a way that's easier to do the division.
Do I?
We're starting with the bigger numbers, the one I highlighted, and we're wanting to break it down into something that's easier to know the division facts for. Everything in the column right next to it, we know rules for. We know rules for 2s and for 3s and for 5s, and we know all those rules, right? So we'd like to be able to break it down. On the list on the left, we can break it down those ways, and it's enough, and it works. If I want to know if something's divisible by 24, I can divide by 8, I can divide by 3, and I know for sure. But if I have the number 24, I cannot divide by 6 and divide by 4, and for sure know if it's divisible by 24. So the list on the left are appropriate things that can be broken down and work. The list on the right, although they break down into those factors, if I do the division with those individual factors, I won't still know whether or not it works. For example, this is the 8th one we did last time. Oops, and I mentioned already. The number 12. The number 12 divides by 2 and 4. It does not divide by 8. Here, 2 and 6. The number 6 itself divides by 2 and 6, but it doesn't divide by 12. Here, the number 125, it will divide by 5 and 5, but it won't divide by 20. That's not true. That one didn't work. I was trying to think of a different one for that one. 25 is just... 25 is fine there. 25 will... No. 5. 5 is what I want. 5 will divide by 5 and 5, but it won't divide by 25. 15 will work too, even. 15 will divide by 5 and 5. But it won't divide by 25. I can come up with example after example after example of why the one on the lists on the left will not work. But the lists on the right always do.
It's about coming. I don't understand what the examples are. Or, like,
Well, if I want to divide by 12, I can just divide by 2 and 3. I'm sorry, 3 and 4. And if it divides by 3 and 4, it will divide by 12. If you give me the number 96 or 100, and I want to know, does it divide by 12? I can check if it divides by 3. I can check if it divides by 4. And if it works, then it's divisible by 12. I don't actually have to divide by 12 to figure that out. But I can't check divisibility by 2 and 6 and for sure know if it divides by 12.
Does that have anything to do with there being even or odd number?
It's a good guess. There does not have anything to do with there being even or odd. Although, odd numbers, if they are odd, will always fall on this list if both of them are odd. What do 2 and 4 have in common? Okay.
They divide into each other. Or like 2 divides into 4.
Okay. Does that work for 4 and 4? Does that work for 2 and 8?
there's the light bulb.
Does it work for 4 and 6 though, Kaylee?
Have a common divisor.
They have a common divisor. I wrote it last, yeah. All of these over here have common divisors.
Bless the Lord.
Can you see it now?
Yeah.
Every pair of numbers in my non-example example list share common divisors. So you can take any number you'd like, and as long as you're able to break it down into things that don't share common divisors, right? That's why I can actually have even and odds on this list. I just can't have 2 evens. But a lot of them showed up with just 2 odds, right? So like 8 and 3 are fine, because 8 and 3 don't share any common factors, but 6 and 4 did. So 6 and 4 don't work. So this rule about divisibility by 6 can be generalized. It's really just about breaking down the number 6 into two factors that share no common divisors. You have to break it down in a way that shares no common divisors. And if you're able to break it down like that, then that's another divisibility rule that you could sort of add to your list. How do I know if something's divisible by 30? I check 3 and 10. How do I know if something's divisible by, trying to think of another one. It's not on my list. How about, how do I know if a number is divisible by 50? I can check 25 and 2, but then 25 would have to be checking 5s and 5s, and that doesn't work. So I don't have a divisibility check for the number 50. So there's some numbers that you can't break down and not have overlapping divisibility. But a lot of numbers, you have the ability to do that.